Hello guys, welcome to another tutorial. In this tutorial, I'm going to show you how to extract data from rasters, which corresponds to specific points. And what's going to be special in this particular tutorial is that I'm going to show you how to use a Python script to extract raster data values for any number of points, just in a matter of few seconds. Now, as an example, the dataset that I'm going to work with you guys today is this average temperature records across the United States, which corresponds to a particular day in the month of November 2021. And my objective would be to extract the corresponding temperature values for each of these different cities that you can see over here. Well, if I were to do the same process manually, you can see that it's going to take quite a lot of time. For example, if I wanted to check the temperature value of Phoenix, well, right over here you can see some sort of a legend from which you can interpret these dark blue and dark red color regions. Well, the dark blue color region corresponds to cold temperatures, and the dark red color patches that you can see over here, in this case you can see that near the state of Florida, in South Arizona as well as in Southeast California. And if I were to check the temperature value of Phoenix, you can see that I can manually obtain the information which corresponds to each of these different pixels using a software like QGIS, and in this case temperature value is 22 degrees Celsius. And similarly, if I were to check the temperature in Denver, I'm assuming that that falls within the perimeter of this pixel, and it's going to be 8.4. And if I check the temperature of Columbus, Ohio, it's going to be 3.79. So similarly, you can see that if I were to do this manually one by one, it's going to take quite a lot of time. So what I'm going to basically teach you guys today is how to first read this capital cities shapefile using Python as a GeoPandas geodata frame. And following that, how we can read in raster data using the Raster.io library. That's also another Python library. And using these two libraries mainly, what I'm trying to do is I'm going to iterate through each of these different points, and I'm trying to extract the corresponding latitude and longitude coordinate. If I quickly open up the attributes table of this shapefile, you can see that what I have is just the name of the states and the corresponding city. So I do not really have the latitude and the longitude just yet, but when we use GeoPandas library to read in data, we can actually extract the latitude and longitude of points quite simply. So I'm going to show you guys how we can do that, and based on that latitude and longitude, I'm going to extract the underlying pixel value for basically all of these pixels. And by now I think you guys can have a clear idea that this method is basically not just a method that works only for temperature data. You can basically work with any sort of raster data from which you would like to extract the raster values for different points. And if you follow along, you'll be able to do that just in a matter of few seconds once you have developed the corresponding script. Alright guys, so without further ado, let's jump in and get started with the tutorial. Alright, so to get started, first of all, I'm going to import the two libraries that I'm going to work with today. That's going to be GeoPandas and Raster.io libraries. So I'm first going to go ahead and import the GeoPandas library. And we'll be importing that as GPD, and in addition to that, we will also be importing the Raster.io library. And we can just randomly assign a name to this library as well. I'm just going to go with RIO. Alright, so the next task would be to import the shapefile that contains those information which corresponds to the locations of the capital cities. And if I head over to these files, you can see that we have that capital cities shapefile, which is basically a point shapefile. So I'm going to import that, and I'm going to save the information into a variable called capital cities, and that's going to be equal to gpd.readfile. We're going to specify the complete path to the location where we have saved this file, including the file name as well. Just like that. And now if you simply run it, you will see that we didn't get any errors or anything like that. We can go to Variables Explorer so that we can be familiar with the way how GeoPandas interpreted this file. And as you can see, it's not a shapefile anymore. When it's being read by GeoPandas, it becomes a GeoPandas geodata frame. And what we have over here is basically the two columns that we saw before. We have the state column and the capital column. But what we have additionally when we read shapefiles using GeoPandas is this special geometry column, which basically defines its geometrical properties. In this case, each of these different row that you see over here is basically corresponding to each of these different points, and the type is basically point, and what you see within brackets over here are the latitude and longitude coordinates of each of these points. And just in a few minutes, I'll be teaching you guys how to extract this longitude and latitude information from this geometry column as well, because we'll be needing that as well when we are trying to extract the temperature data corresponding to a specific latitude and longitude. Alright, so before we head over to the next step, I'm going to create one additional column, because after I extract the data, if I head back to this variable, I would like to save the temperature that was extracted for each of these different cities, maybe in another column somewhere over here. So it would be convenient before we proceed further to actually create maybe an empty column which has the title something like temperature or temp or something like that, so that later on we can actually, once we extract the data, we can fill that in conveniently. So I'm going to say capital cities, and over here we can specify the name of the column. Just going to say temp. And for the time being, I'm going to make it equal to 0, because we still haven't actually extracted anything properly yet. If you go over here, you will see an empty column. Basically, it's filled with zeros right now. So the next step would be to iterate through this GeoPandas geodata frame. And while doing that, I'm going to extract 3 different things. The first one would be the name of the capital city. The second one would be the longitude value. And the third piece of information that I'm going to extract would be the latitude value. So now let's see how we can do that. So in order to iterate through this capital cities GeoPandas geodata frame, what we need to do is we have to create a simple for loop for index row in dot capital cities dot iterows. Well, if you're not really familiar with what's going to get printed, always it's a good idea to just pass a print statement and maybe print some things just so that you'll be familiar with how it's going to get executed. For example, if I just print the row, apparently there's a spellings mistake. So what you can see over here is basically the same information that we saw in this table, but over here you can see the formation is a bit different. We have the state over here. It basically becomes the index, and this becomes the first entry. So what we have to do is now pass the argument like this. Let's say if you want to extract only the name of the state or only the name of the capital. In this case, I'm interested in extracting the name of the capital. So if I pass the argument capital over here, it's going to basically extract the capital city. And similarly, I would like to extract the X and the Y coordinates as well. So I think we won't be needing this anymore. So I'm going to assign a new variable called, or maybe we can just name it as city. That's going to be this row capital city, and the longitude would be row, but in this case we are going to refer to that geometry column that we saw. And in that geometry column, we have to specify the longitude to be the X value. And similarly, the latitude value is going to be the Y value. We can even do a quick check. If I just say raw geometry, it's just going to print this point over here, because now it's a shapely point object. But if I want to extract the X value of that point, all I have to do is just say .x, and that's going to give me the X value, which is the longitude value. And if I need the Y value, all I have to do is just pass the argument .y, and this one needs to be latitude. Alright, now I can simply go ahead and run and make sure that I don't have any errors or anything like that. And the next step would be to read the actual raster data. So we can make use of this raster.io library that we just imported in order to read the raster data. So I'm going to create a variable called temperature raster, and that's going to be equal to RIO. Instead of typing raster.io, I'm going to make use of this shortened version RIO, and then .open. So what this does is this is basically opening the dataset for either reading or writing data. And similar to what we did over here, all we have to do is just pass the full path to the location where we have saved the raster. So that's going to be this. And this is going to be my file name of the raster. So I'm going to go ahead and copy that as well. And now what we are going to do is we are going to actually read the data. So I'll say temp data, it's going to be a new variable, and that's going to be equal to this temperature raster dot read. And over here we have to pass an argument which corresponds to the number of bands. Now in this case we are actually not working with the multi-band data, we're just working with a single band temperature raster. So that's the reason why we just specify one over here, corresponds to just a single band data set. And now what we can do is we can even do a quick check to visually see what this temp data variable actually looks like. Maybe we can head over to Variable Explorer, and if I open this up, now each of these different values that you're seeing over here are basically the real values that were extracted from the raster itself. And if you head over to this actual raster, well, what you can see is the raster has been more or less cropped. Well, it's not a perfect crop which matches exactly this outer boundary of USA, but with a certain buffer you can see that it does follow this outer boundary of the country. When it comes to GeoPandas actually reading the file, you can see that it's basically reading the file assuming that the entire raster is a rectangular raster, but for areas where it doesn't have data, it's basically assigning this large value so that we can clearly distinguish between the actual data points and the regions where it just assumes that we don't really have any data. So you can see that in the top left corner, definitely we do not have any data. And when I slide it over, you can start seeing actual temperature data. Now this corresponds to the mid part of the country where the temperature data is actually present. And again, when we go towards the corner, you can see that it basically interprets these areas with no data to be this particular number. Later on, when we try to extract the data from a particular cell, we need to specify the corresponding index. Now in this case, you can see that this data point is actually located at 19,25 index. So we need to specify the index in terms of the row and the column. In this case, it's 1925. So that's how Raster.io will be able to basically extract this value which corresponds to the exact location of the real city. So that's going to be our next task. So now we'll see how we can basically extract the index and the row which corresponds to each of these different longitude and latitude values. Now before I execute it over here, what I'm going to do is I'm going to basically do a test and show you guys how that line of code would work. So at this time you can see that under longitude and latitude we have these longitude and latitude values. So I'm going to basically demonstrate to you guys how we can extract the corresponding row and column which corresponds to this particular longitude and latitude. And that's simply by specifying two variables like this. And this is going to be equal to tempraster.index, because what we are trying to do is we are trying to retrieve the index which corresponds to a particular latitude and longitude. Now in this case, since I'm trying to demonstrate this to you guys, I could simply copy these two values. But since we are trying to later make it part of this particular loop, I think we can simply go ahead and copy this longitude and latitude variable names, because in this case, this value has already been saved into this variable. And similarly, this value has been saved into this variable as well. So I'm just going to go ahead and say this is longitude. And the second argument is latitude. And now if I hit enter, we will see two more variables called row index and column index. And in this case, you can see the row index is 28 and the column index is 50. So again, just before we proceed to the next step, if I were to explain this again very quickly, and as you can see over here, every raster is made out of different pixels, and you can imagine this entire image to be sort of a huge matrix which contains temperature data. And the way we are going to retrieve the location of a particular cell is simply by identifying the corresponding row and the column. And in this case, when it comes to this particular longitude and latitude, the corresponding row index and the column index happens to be 28 and 41. And now since we are inside a loop, what we can do is instead of specifying this over here in the IPython console, we can simply copy this and paste it over here. So as it's iterating through our GeoPandas geodata frame, it's going to record this corresponding row index and the column index during each iteration, which corresponds to different sets of longitude and latitude, which again corresponds to each of these different cities that we saw over here under this capital cities variable. And now what we can do is we can simply pass a print statement, and we can print out during each iteration. We would like to see the name of the city that's going to get printed. And maybe we can leave a bit of a space over here. And following that, we can extract the actual data that corresponds to this row and column index that we discussed just now. So we'll go ahead and run this, and we'll see whether we are going to face any errors or not. Yeah, as we can see, this item is actually going to be of the type, well, it's going to be a temperature value, which corresponds to this different row and index, whatever that got recorded during each iteration. But if you check the type, that's going to be of the type float. And you cannot add floats and strings together. So what I'm going to do is I'm going to convert this to a string sort of on the fly. And I will add this to these two things that I specified over here. Well, the city is going to get recorded as a string. And now if I run this, you can see that it's going to instantly extract temperature values of each of these different cities. And after it goes through this process of first opening the raster, and then reading the raster and saving those raster data into a variable called temperature data or temp data. And following that, it's going to identify the row and the column index, which corresponds to the actual location of this longitude and latitude. And based on that, what it's doing is it's retrieving the actual raster value, which happens to be the temperature value, which corresponds to, again, this particular row and column index. And it's always a good habit to basically head back to the original dataset and maybe do a couple of checks here and there. For example, if I want to check whether the value that we obtained for Phoenix, this 22.19 Celsius, whether it's correct or not. And we have Phoenix over here. So the temperature value of Phoenix will be given from this pixel that you can see. And I'm going to take this identify features tool, and I'm going to right click over here, and I'm going to specify the name of the raster. And right over here, you can see the temperature value is 22.19, which basically matches with whatever we had before. And if I quickly do a second check, if I go to this Raleigh in North Carolina, maybe we'll go back and check. That should be somewhere over here. Yeah, so when it comes to this pixel, the temperature value is 7.15, which again agrees well with whatever got recorded over here. So I think you guys can see the benefit, especially if you're trying to extract information which corresponds to a number of data points. Doing it manually, it's going to be actually quite a tedious task. And this method can not only be used for temperature data, that's the other advantage. You can basically use this for any type of raster data. I mean, it could either be land cover or land use type of data. It could be elevation data. It could be maybe another climatic variable. As long as you can use this raster.io library to read that raster data, this particular piece of code is actually going to get executed with no issues at all. And you'll be able to extract the data which corresponds to any number of points just in a matter of few seconds, basically. Alright, so to finish this up, what I'm going to do is I'm going to record this information that we obtained into another table, or basically another pandas data frame. What we can do is we can actually make use of this GeoPandas geodata frame that we have over here, and we can fill this column up with the actual temperature data. And after that, we can maybe get rid of this geometry column and save this into a pandas data frame, and finally save this into a CSV file as well. So now we'll see how we can actually take this extracted temperature data and how we can save it into the corresponding temperature column that we created for each feature. So I'm going to say capital cities, and over here during the iteration, the way I'm going to identify the location is basically by index, and that's going to be equal to temperature data, and it's basically the entire line of code that we specified over here. So I'm going to replace this entire thing, and that should get the job done. Yeah, now if I go to Variables Explorer, you will see that we have this temperature column with the actual temperature value recorded in here for each of these different cities. And I'm going to go out of this loop because what we want to do is basically done by the time we reach this line of code. And once the process is done, I'm going to take this GeoPandas geodata frame, and I will basically isolate only the columns that I need. That's going to be state, capital, and temp. So we can simply pass those arguments here. And now if I run this, and if you check the capital cities variable, now it's going to be a pandas data frame. You can actually do a double check over here by checking the type of capital cities. It's a pandas data frame. Before it was a GeoPandas geodata frame having that special geometry column, but we basically got rid of that because we are trying to sort of shave off the information that we don't really need and save this finally into capital cities.tocsv. And we can specify the full path over here. If not, you can simply just give the file name. It'll get saved to the same location where you actually save your Python script. So in this case, I'm just going to pass capital cities with temperature.csv. And if I execute and run this command, that file is going to be this. So let's go ahead and open that up. And finally, this is how it's going to look. And you can see we have the state, capital, and the temperature column, just as we expected. And that brings us to the end of this tutorial. So I hope what we discussed over here was clear for you guys. If you do have any questions, you know exactly what to do, put a comment down below and we'll see what we can do to clear up those doubts for you guys. And as always, if you did enjoy the tutorial, show your support by hitting that like button, and you can even consider subscribing if you find this kind of material quite interesting. And I'll see you guys with another tutorial.